to this very important practice session on the subject of fluid mechanics. I'm Vikas Sir, your faculty for the subject of fluid mechanics for this session. And I will be taking some important questions for the GATE 2025 exam, which is going to be held in the month of Feb. And so not very less time is left. And so we are providing you this practice session. Today, I will be taking some important questions on the subject of fluid mechanics for all the civil and mechanical students. So just please reply in the chat box if my audio and video is clear. Yes. Please reply in the chat box if my audio and video is clear and you are getting the clear audio and video. Good evening, everyone. Welcome to this session. So if you are getting my clear audio and video, just reply in the chat box. Good evening, all of you. जी सर, चलिए बढ़िया है. शरद, हाउ आर यू? आप मुझे एक बार बता दीजिए आपको लैंग्वेज कौन सी प्रेफर करेंगे आप लोग. यू वांट मी टू टीच इन इंग्लिश लैंग्वेज और हिंदी लैंग्वेज? वेरी फाइन. ओके, वेरी गुड. जस्ट अ सेकेंड. शरद मैस, सैयद, प्रियांशु नेगी, गुड इवनिंग. अनात्मा फातिमा, गुड इवनिंग, वेलकम टू द सेशन. गुड इवनिंग एवरीवन, कैसे हैं आप सब लोग? हाउ आर यू गाइस? श्रवंत, गुड इवनिंग. सो तनेश गुप्ता, गुड इवनिंग. प्रियांशु, DR प्रसाद, हरिनाथ, जोलू, गुड इवनिंग. गुड इवनिंग ऑल ऑफ यू. वेरी गुड इवनिंग. Okay, so let's start the session. You can directly see this is some details given about me in case you guys are not familiar with the faculty. That is me. I'm Vikas Sir, your faculty for today's session. And these are the expertise subjects: fluid mechanics and thermodynamics, applied thermodynamics. So I will be taking these two practice sessions. Today I will be taking important questions on the subject of fluid mechanics. And the next session, which will be in the next week, I will be taking the questions on thermodynamics and applied thermodynamics, which is only for the mechanical, but this is common for civil and mechanical. Okay, so all the civil and mechanical students who are prepping yourself for GATE 2025, you can follow this session. Priyanshu, good evening. Vinay, good evening. कैसे हैं आप सब लोग? English, okay, you want English? Okay, no problem. English जो देखिए, जो भी आपको चाहिए. इफ यू वांट मी टू स्पीक इन इंग्लिश ओनली, इफ यू वांट मी टू स्पीक इन इंग्लिश हिंदी, आई कैन डू दैट. आई प्रिपेयर वेल बट आई गॉट वेरी लो मार्क्स इन टेस्ट. हाउ टू इम्प्रूव सर? हरिनाथ, follow our right strategy. If you want to excel in the test, just follow the right strategy. And the right strategy to score better is, firstly, do the revision. First revise the concepts. Right? And then practice. Follow this habit of revision for every subject. Firstly, revise all the subjects. If you are individually practicing the question of subjects, then firstly do the revision of entire subject, then practice. And in the practice, whenever you solve the question, when you just analyze your mistakes, okay, what mistakes you are doing in the test, okay? Is plastic analysis enough from steel? Anna Puneshwari, I am not from the, I'm not having the civil background, so I'm sorry, I cannot answer this question. Okay, I'm a mechanical faculty, but I am teaching the subject of fluid mechanics, so I can't answer this question from steel. If you are having any question like that, particularly from civil background, you can ask Abhinav Negi sir. Okay, let's start the first question. This is question number 1. A square plate 50 centimeter into 50 centimeter weighing 200 Newton is allowed to slide down an inclined plane, which is laid at a slope of 1 vertical to 2.5 meter horizontal. What terminal velocity will be attained by a plate if 0.02 mm thick oil film is interposed between the inclined plane and the plate? The oil has a dynamic viscosity of 2.25 into 10 power minus 3 Newton second per meter square. Report the answer in meter per second. Yes, this is a question from fluid properties. Okay, and you have to find the value of terminal velocity. How are we going to solve this question? First of all, we need to draw the diagram. So we are having an inclined plane. You are having an inclined plane like this. Okay, this is, let's say, the horizontal surface, and this is the inclined plane. Okay, and the angle of inclination is theta. Now a square plate having this dimension 50 into 50 centimeter. So let's say there is some fluid which is present here. There's some fluid present here, over here, and over this fluid 0.02 mm thick oil film is present. So this is an oil film, and this oil film is having the thickness of the oil film is how much? 0.02 mm. Okay, that is the thickness of the oil film. This thickness of the oil film is equal to 0.02 mm, and a square plate is kept here. A square plate is kept over this plate like this. Okay, now if you superimpose this plate, superimpose means like if you project this plate, it will look like this. It will look like this. So this is 50 centimeter. This is 50 centimeter. This is a projection of this square plate. This is a square plate. If you project it, it will look like this. Now the angle is given as, this is 1 vertical and 2.5 meter horizontal. So from this you can calculate the angle. This theta will be, you can calculate tan theta. Tan theta will be equal to 1 by perpendicular by base, 1 by 2.5. So you will get, which is 0.4. So you will get theta is equal to tan inverse of 0.4. You will get this angle of inclination which will be equal to 21.8 degree. Okay, understood? Now let's say this plate, the weight of the plate is acting in this direction, and if you resolve this weight, it will be having two components. One will be W. You are getting angle as 2.64. Sayyid Muhammad, you are getting 2.64. Please cross check that. 1 meter vertical, 2.5 horizontal. You can calculate the theta. Tan theta will be 1 by 2.5. Just a second. 1 divided by 2.5. Find the inverse of it. Inverse of tan inverse of 0.4. 21.8. You will simply get 21.8. How are you getting to 2.64? Use calculator. Okay, you are saying velocity 2.64. Okay. Smart, huh? Okay, you are directly getting 2.6. Let me just verify it. Your answer is correct. Absolutely correct. Terminal velocity will come as, very good. Your answer is correct. Terminal velocity will be equal to 2.64. Anyone else? Anyone else getting this answer? Very good. Now we have got this answer. Now, if you resolve this weight, this is weight of the plate. This will be W cos theta, and this weight of the plate along this direction of the flow will be W sin theta. Okay. W cos theta, and the weight is 200 Newton. So W is equal to 200 Newton. Weight is equal to 200 Newton given here. Angle is, yeah, Shravanth, your angle is correct. Guys, you try to just solve the question along with me. Okay. Now we can simply, we can assume a linear velocity profile. If nothing is given, you can assume a linear velocity profile. So for linear velocity profile, according to Newton's law of viscosity, shear stress is equal to mu du by dy. So you can write mu into v, velocity divided by thickness. Okay, you can write like this. Now, if you see this plate and you draw the diagram, free body diagram of this plate. So on this plate, what is happening? Weight W is acting downward. This angle is theta. This will be W cos theta. this will be W sine theta. Okay, W sine theta will be in this direction. Okay. So what will be the shear? So we can say opposite to this will be a drag force. A drag force will act in the opposite direction, right? A drag force, or basically this is the shear force. So if shear stress is this, what will be shear force? Shear force will be equal to mu into A into V by T. And in equilibrium condition, W sine theta and this drag force or shear force will be same, equal. So drag force will be equal to W sine theta in equilibrium condition. Drag force is equal to mu into A into V by T, terminal velocity. W is 200 into sine of 21.8 degree, right? From here you can calculate the value of velocity. They have given the viscosity, dynamic viscosity. Dynamic viscosity is given, that is, so you can get the value of V from here. V will be equal to 200 into sine 21.8 into T divided by mu into A. Okay, solve it, you will get the answer. You will get the same answer, 2.64. Are you getting the answer, everyone? Tell me. Now, how you find the area? Area we can find by, area will be equal to 0.5 into 0.5, which will give you the area. Mu is equal to 2.25 into 10 power minus 3. And thickness is 0.02 into 10 power minus 3. Just put these values in this equation and you will get the answer. 2.64 meter per second. This will be the terminal velocity. Okay. The terminal velocity will be 2.64. Are you getting this answer, everyone? Tell me, everyone, quickly. I want all of you to cross verify this and tell me, have you got the answer? आप सभी का आंसर आ गया है, बताइए. अगर आपको इंग्लिश में कंफर्टेबल नहीं है तो मैं हिंदी भी बोल सकता हूं, मैं इंग्लिश भी बोल सकता हूं, इंग्लिश हिंदी दोनों बोल सकता हूं. I can speak in both the languages. So you can just tell me, have you all got the answer, all the 16 students present in the lecture? Have you got this answer, 2.64 meter per second? You can put oil thickness is 0.02 mm, which is 0.02 into 10 power minus 3 meter. Area will be 0.5 into 0.5 meter square, and dynamic viscosity is 2.25 into 10 power minus 3 Newton second per meter square, that is Pascal second. Okay. Next question, an increase in the pressure of a liquid from 7.5 megapascal to 15 megapascal results in 0.2% decrease in its volume. Determine the coefficient of compressibility of the liquid. Yes. कैसे solve करेंगे आप इस question को? How are you going to solve this question? I don't know why the students are slowly declining from the session. Guys, please, I will be taking 1 hour 30 minutes, maximum 1 hour 30 minutes of your time, and we'll be solving very good question, nice question from entire. And today I have got the question from entire fluid mechanics and machinery. So the question will be from fluid mechanics and machinery. Okay. That is fluid machinery also. What is coefficient of compressibility? You know that compressibility is reciprocal of, compressibility is equal to 1 by bulk modulus of elasticity. Have you solved the question? Bulk modulus of elasticity. Bulk modulus of elasticity is K, and the formula is increase in pressure to the decrease in volume over original volume. Syed has got option C as the answer, 0.267 10 power minus 9. Anyone else? और किसी ने solve किया? Have you anyone else? Okay, Shravant has got the answer, option C. Okay. So you can firstly find the bulk modulus and then you can do a reciprocal of it. So it is very obvious these two cannot be the answer. Why? Because Bulk modulus of elasticity have a unit of Newton per meter square. This has a unit of meter square per Newton. So these two cannot be the answer straight away. The answer can be either option C or option D. And most of you are giving option C as the answer. Very good. See, you can firstly find the increase in the pressure, which is 15 minus 7.5 into 10 power 6 Newton per meter square. To the percentage decrease is 0.2%. That is, this will be 0.2 by 100. Solve it, you will get the answer from here. Firstly, you will get the value. Firstly, you will get the bulk modulus, and then from the bulk modulus, you can find the value of bulk modulus will come out as 3.75 into 10 power 9 Newton per meter square, and compressibility will be equal to 1 by 3.75 10 power 9, which will give you the answer 0.267 10 power minus 9 meter square per Newton. Next question. A block of steel floats at a mercury water interface as shown in the figure. So you can see there is a steel block. This steel block is floating on the interface of mercury and water. So one side you have mercury, other side you have water. Okay. And this steel block is floating at the interface of both. You need to find the ratio of A and B for this condition. Now, since this block is floating at the interface of water and mercury both, the weight of this block, the weight of the block will be equal to, now on the steel block what will happen? There will be a buoyant force which will be acting in the upward direction due to water, and there will be one buoyant force which will be acting due to mercury in the upward direction, right? Are you getting this? So what will, according to Archimedes principle, we can say that the weight of y 10 power 6, very good question Hariyan, very good question. See, this is given in megapascal. Megapascal means 1 megapascal is equal to 10 power 6 pascal, and 1 pascal is equal to 10 power 6 Newton per meter square. Because they want the answer in meter square per Newton, that is why we have to multiply with 10 power 6 so that you can get the answer in Newton per meter square. Meter square per Newton. Okay? Understood? Shrishti, your answer option D is absolutely correct. Very quick and very fast. Very good. Archimedes principle is weight of the steel block. Weight of the steel block is equal to the buoyant force of buoyancy due to water plus force of buoyancy due to mercury. Right? That is, on this steel block, there will be one weight which is acting downward, right? And there will be two buoyant forces which will be acting because of mercury and water. So this is the basic concept first. Now, let's say that this steel block which is having this, here you have water and here you have mercury. Let's say this height is B, which is given here B, and this is A. Now let area of the block is, area of steel block is A. Let us say area is A. Now what was the question? What was the Archimedes principle? Weight of the steel block is, weight of the steel block will be equal to M into G. And what is M? Mass is density into volume. So density of the steel block into G into volume of the steel block, to G into volume. Volume is, so how you will find the volume of the steel block? Volume of the steel block will be, volume of the steel block will be equal to area into the total height. This total height, right? That is A plus B. That is, this will be area of the steel block. Yeah, come on guys, why your number is declining from the class? Are you afraid of these questions? अगर आपको क्वेश्चन से डर लग रहा है तो आप जा सकते हैं, लेकिन डरने से आप क्वेश्चन को एग्जाम में तो फेस करना ही पड़ेगा. Ultimately you have to face the question in the exam, right? So there is no point of running away from the questions. The buoyant force due to water will be, buoyant force is equal to weight of fluid displayed. Weight of fluid displayed. And weight of the fluid displaced is equal to density of the fluid, that is density of the water, into G into volume. What is volume? A into this height, that is A. This will give the volume. Similarly, buoyant force due to mercury will be, buoyant force due to mercury will be equal to weight of fluid displaced due to mercury. Buoyant force is equal to weight of fluid displaced, that is equal to density of the mercury into G into area into B, because this is B, the height is B. So we can apply this concept. Weight of the steel block is equal to buoyant force plus buoyant force of water plus mercury. Just put all the values here. Just a second. So weight of the steel block is, weight of a steel block is equal to buoyant force due to water plus buoyant force due to mercury. Just put the values here. If you just put the values, weight of steel block was, this is the weight of the steel block, that is density of the steel block, into G into area into A plus B. Buoyant force due to water is density due to water into G into A plus density due to mercury. If you are having any problem in any of the points, you can ask me, any of the line you can ask me. Now, in this question, they have given that specific gravity of the steel block is 7.85 and specific gravity of mercury is 13.57. If you know the specific gravity, can you find the density? Density of the mercury will be equal to 13.57 into 1000, right? That is 13570. And density of the steel block will be, equal to 7.85, that is 7850, right? Put the values. This is 7850 into G, or directly we can just cancel it out. We can cancel this out. This is going to get cancelled out. G into A is common here. 7850 into A plus B is equal to density of water, which is 1000 into A plus 13570 into B. Solve this equation. When you solve this equation, you will get A by B as 0.835. Yes, everyone, are you getting this? क्या आप सभी का आंसर आ रहा है ये? प्लीज बताएं. Anyone facing any difficulty so far? Tell me. Okay, moving on to the next question. Two pipes A and B are at the same elevation. This is pipe A and this is pipe B. They are at the same elevation, same height. Water is contained in A, in pipe number A. This is pipe A. Okay, this pipe is containing water. Is diagram clear to everyone? This pipe is containing water, and this water is rises to a level of 1.8 meter above it. Water in the pipe is rising to a level of 1.8 meter. Okay, in right limb of a manometer, obviously they are using a manometer. In the right limb, carbon tetrachloride having a specific gravity of 1.59 is contained. Right limb means in this limb they are having carbon tetrachloride. Okay, the inverted U-tube inverted U-tube is filled with compressed air at an absolute pressure of 300 kilonewton per meter square. That is, this is containing compressed air. Inverted U-tube manometer is containing compressed air, and the pressure of the compressed air is this much. Temperature is this. If Z is equal to 0.45 meter, this Z is 0.45 meter, then absolute pressure in B, in meter of mercury, you have to find. Very good question. And in this question, this R, this is called as gas constant of air. Gas constant of air. And this is density of mercury, which is this. Why they have given density of mercury? There is a reason for that, because you have to find absolute pressure in meter of mercury. That's why they have given density of mercury. So how are we going to solve this question? To solve this question, I will be taking this diagram in the next page. Let me just one second. Okay. So let's visualize this diagram to understand the question. So what is happening in this? So if you see this pipe number B, okay, if this is 1.8 meter, if this is 1.8 meter, if I just take pipe number, if I take this pipe just, pipe number B, what is happening here? So pipe number B, if you visualize it, on this side, the pressure of the air is acting. Air is applying the pressure, because here we have compressed air, and compressed air is applying the pressure of, how much? 300 kilonewton per meter square. This much pressure is applied by the compressed air. Okay. And because of this application of the pressure, or let's say here, if you visualize this, pressure is applied, pressure of the air is 300, okay, kilonewton per meter square. As a result, if this is 1.8, this is Z, right? So what will be this height? So this is a point, this point. What will be this height? This will be 1.8 minus Z, right? Just see, just focus on this diagram. What will be this height? This height will be 1.8 minus Z, correct? So what we can say about the pressure of at point B? Pressure at point B, that is at this point, what will the pressure? That will be equal to pressure of the air plus, now this liquid here is carbon tetrachloride. Carbon tetrachloride is present here. Tetrachloride. And it is having the specific gravity of, what is the specific gravity of carbon tetrachloride? 1.59. 1.59. Okay. So specific gravity is 1.59. So density will be equal to 1.59 into 1000. That is 15900. 15900 into 9.81 into 1.8 minus Z. Now Z is equal to, what is value of Z? In the question, Z is given as 0.545 meter. So pressure of the air is equal to 300 kilonewton per meter square. 310 power 3 plus 15900 into 9.81, 1.8 minus 0.45. Can you calculate the pressure at point B? What is the pressure at point B? That will be 321.05 kilonewton per meter square. This will be the pressure at point B in this right limb. Okay. Now this pressure we have to convert. We have to convert this pressure in meter of mercury. Understand? How you will convert this in meter of mercury? Now pressure at V will be equal to density rho GH. So in terms of meter of mercury, you have to convert this pressure at point B is equal to density of the mercury into G. So pressure is 3 to 1.05 10 power 3 Pascal divided by density of the mercury is 13600. See, density of the mercury is 13600 into 9.81. So you will get this value, which is 2.406 meter. So this is the answer, 2.406 meter of mercury. The absolute pressure in point B is 2.4606 meter of mercury. Understood? Have you all understood this question or not? Tell me. So we have calculated the pressure, absolute pressure. That's why we have added the atmospheric pressure, pressure of the air here, plus the gauge pressure, which is the height up to this is 1.8 minus Z. We have calculated into density into 9.81 G. And we have added the pressure of air because this is atmospheric pressure. Atmospheric pressure plus gauge pressure is absolute pressure. So this is absolute pressure. So we have firstly calculated the total absolute pressure, and then we have converted this into absolute pressure head. Okay? Absolute pressure head. Next question. A 60-degree water gate of 3.6 meter radius is mounted on the spillway of the dam as shown in the figure. So this is a gate. The gate is like this. The gate is AB. This is a gate. Okay. This AB is the gate. And this gate AB is mounted on the Victor. Yes, Victor, we have to use the density of mercury. We have to use density of mercury for H instead of, yes, my dear. That's why we have done this. Why? What's the reason why we have done this? Because they want the answer in terms of meter of mercury. They want the answer in terms of meter of mercury. That is the reason we have divided by density of mercury. To convert this into pressure head, we have put density of mercury, not relative density of carbon tetrachloride. Okay, that's the reason. Anyone else having any doubt in this question or any of the question? Tell me. Any doubt? Have you all got the answer? Is it a tough question? Do you find the question tough? So I have taken the question from almost all the topics. This is a question from hydrostatic forces and buoyancy. Hydrostatic forces. So we have this gate, and the angle at which the gate is inclined is 60 degree with the horizontal. Okay. Its hinge C. This is a hinge. You know, hinge, a support, a fixed support, and one of its end radial arm AC are at the same horizontal level. Radial arm, the radial arm of this gate is limb is rising. See, obviously, it is a very common sense that air is applying the pressure on this side. Air is applying pressure on this side. So air is the liquid on this side will be obviously, we can say, this liquid here in the pipe, the liquid in the pipe here, water is applying the pressure. As a result of that, if water level, it is mentioned that water level is rising to a level of 1.8 meter, right? If water level is rising to this level in this pipe, the level of the liquid here, the carbon tetrachloride, the carbon tetrachloride level has fallen down. The level of carbon tetrachloride was here like this. So level of carbon tetrachloride has fallen by this height, 0.45 meter. Okay. Understood? The water level in this, if water level in this pipe is rising, so water level, see, carbon tetrachloride level has fallen down. How much level it has fallen down? It is fallen down by a level of 0.45 meter. Okay. So how are we going to solve this question? Yes. First of all, we need to calculate this height. Okay, this height h. How will calculate h? I'm not happy with the kind of response I'm getting from the class. H will be equal to what? It is equal to BD, which is equal to BC sine 60 degree. Okay, so you will get this as BC is equal to 3.6. So what is sine theta? So remember that sine theta is equal to perpendicular. Perpendicular is this, perpendicular by hypotenuse 3.6. Perpendicular, that is h by 3.6. So this will be, h will be equal to, this will give you the value of h from here. So sine 30 degree will be equal to, sine 60 degree will be equal to perpendicular by 3.6 hypotenuse. Okay. So when you solve this, you will get h, this vertical height will be equal to 3.6 into sine 60 degree, and that will give you the answer as 3.12 meter. So we have got this h. Fishti, your answer option C is 39.27 and 11.170. $185. Option C is correct. Very good, Srishti. Very good response. So how will find the horizontal force? Horizontal component of hydrostatic force. Firstly, you have to find the horizontal component of hydrostatic force on space AB. And how you will find this? That is simply going to be equal to, let me just take the diagram on the next page. Okay, so we have to find firstly the horizontal component. Horizontal force will be horizontal component of hydrostatic force will be, Nandi, your answer is correct. Very good. Hydrostatic force will be equal to hydrostatic force on projected area of vertical plane. Okay, it is a curved surface. So in curved surface there will be two forces. In the curved surface you have to find the horizontal force and vertical force. So resultant force will be what? The resultant force will be equal to square root of horizontal force plus vertical force, right? So firstly we'll find the horizontal force. Horizontal force will be equal to 9.81 into so this is 3.12. So this will be, so this height we have calculated as, this total height is how much? This is 3.12. Okay. So area will be, hydrostatic force will be what? If you see the projection will be like, how you will see the projection of this? The projection on the vertical plane will be like this. So hydrostatic force will act, this is H bar. H bar will be rho G A H bar. Rho is how much? Obviously we have to take density, that is 1000 into 9.81 into area. Area will be equal to, so the width of the gate is 3 meter, right? Width of the gate is 3 meter and the height is 3.12. And what is H bar? H bar will be equal to H by 2, right? So it will, H bar is the position of centroid, that will be 3.12 by 2 into 3.12 by 2. You will get the value of horizontal force. So horizontal force will be 143.242 kilonewton. Have you got the horizontal force, everyone? Have you got the horizontal force? How will you find the vertical force? Now vertical force will be equal to, it will be equal to weight of the imaginary volume of water on curved surface AB, right? So whatever is the weight of the fluid here, whatever is the weight of the fluid of the water of the curved surface, whatever water is present here, the weight of that fluid will give you the vertical force. And how you will find the weight? Yes, weight is equal to mg. Weight is equal to m into g. M is equal to density into volume into g. But we have to find the volume. Challenge is to find volume. How will find the volume? So we have to find the volume of the entire and volume will be equal to volume of, you have to find the volume of ABD, or we can say volume is equal to area into height, right? Area is equal to area of ABC into height is equal to 3 meter. Sorry, width, not height, width. So width is 3 meter. Now we need to find the volume of area of ABC. How will find the area of ABC? I will find the area ABC. So basically we have to find this area A, B and C, this total area, right? We need to find this area ABC. So area ABC will be equal to, it will be equal to area of section actually not, we have to find area ABD, area of ABD, area of section ABC minus area of triangle BCD. So basically we need to find this area. We need to find this area. So how you will get this area? From the total area of the section of a circle, right? If you find this total area ABC and you subtract this area of a triangle BCD, you will get the area ABD, correct? What is the formula for area of a section? Area of a section is equal to pi into r square by 6, okay? Minus area of a triangle will be equal to half of DC into DB. That is DC is this and DB is this, right? Half of base into height. It will give you area of triangle. Just put all the values, you will get the answer for the area. So DC will be equal to what? DC will be, now cos 60 degree is equal to what? Cos 60 is base, that is DC, divided by height, that is 3.12. So DC will be equal to 3.12 cos 60 degree, correct? Yes guys, are you solving this? So you will get DC from here, and how you will get DB? DB is equal to 3.12, okay? So put all the values, just a second. Put all the values here, you will get the value of area. So area of ABD is equal to, that is pi by 6 into 3.6 square. Why 3.6? Because water gate is having radius of 3.6. Radius of the water gate is 3.6 meter. Okay. Cos 60 degree is wrong. Why cos 60 degree is wrong? If you have to find DC, cos 60 degree will be what? Cos theta is base. This is the base. Sorry, hypotenuse. Sorry. It will be BC, na? But half of base into height. So base into height. Sorry. Half of this will not be DC. Cos theta will be, cos 60 degree will be equal to base, that is DC, divided by hypotenuse BC. Now BC is equal to what? This is equal to 3.6. In this diagram, BC is equal to 3.6 meter. That is the radius. So DC will be equal to 3.6 into cos 60 degree. Now it is correct. 3.6 minus half of 3.6 into cos 60 degree into 3.6 into sin 60 degree, which is 3 point, because dB is equal to what? dB is equal to 3.12, which is 3.6 into cos 60 degree. Just put the values, you will get the answer of area. Area will be 3.98 meters square. So we will get the vertical force. Vertical force will be equal to 9.81 into 1000 into 3.98 into 3. So you will get the vertical force, which is 117.131 kilonewton. The resultant force will be equal to square root of horizontal force, square of horizontal force or vertical force. So you will get, this will be square root of horizontal force is how much? 143.242. 143.242 square plus vertical is 117.131 square. So you will get the resultant force 185.03 kilonewton, and tan theta will be equal to vertical force by horizontal force. See guys, when in previous question inverted manometer, why don't you calculate pressure at pipe A? See, if in the question they have mentioned to ask the value of absolute pressure at point B, so why I'll be calculating the pressure at point A? Alien, you have to use your brain. You don't have to make the question complicated, right? Sometimes questions are already lengthy, but sometimes the solution is very simple. Because you have to find the absolute pressure in B, so why are we going to find anything for the pipe A? The matter of concern is point B, where you have to find the absolute pressure at point B in the pipe B. So that's why we are not going to do anything in the pipe A, right? We have calculated this height, right? 1.8 minus Z, the total rise in the level. This is a fall in the level. So we have calculated this height, and we have calculated the absolute pressure at point B. So this pipe is not our concern. That's why we have done the calculation for pipe B. Okay. We'll get tan theta from here. That is, when we calculate it, it will be 117.131 divided by 143.242. You will get tan theta, which will be 0.8177, and theta will be equal to tan inverse of this 39.27. I don't answer the question which एलियन, देखिए आपको इतना टाइम नहीं है मेरे पास कि क्या व्हाट इफ पूछा जाए तो आप क्या करेंगे. if you have to find the pressure at what if, I am not here to answer the questions like what if. Okay, if you have not studied the theory of manometers, you can go through the theory lectures. Okay, in that I have discussed how to calculate the pressure difference with the help of inverted manometer. We can use jumping method, or you can use the pressure equation. Okay, here I am not going to address any additional questions. If you have any other queries, you can personally discuss later on. The velocity field for a flow field is given by this equation. Density varies as this. In order that mass is conserved, the value of lambda should be. In order that mass is conserved, if mass is conserved, continuity equation has to be satisfied. Continuity equation has to be satisfied. And what is continuity equation? If density is given, time is given. Density is given like this. Density is equal to rho is equal to rho naught. This is exponential. Exponential means e power minus 2t. Okay. So there is no time for research, my dear alien. Okay. Your name is alien. Don't behave like an alien. Here we have to address the questions what have been asked. You don't have to do any research here. Okay, and neither you have to do research in the GATE exam. There's no time for this. This is the equation, right? This is the equation, continuity equation for unsteady flow, and if it is three-dimensional flow. It is a three-dimensional flow. Unsteady flow will be using this equation. Density is given as a function of time, and u component of velocity is 5x plus 6y plus 7z. V is equal to 6x plus 5y plus 9z, and w is equal to 3x plus 2y plus lambda z. We have to find the value of lambda, right? Just put all these parameters in this equation. U is equal to 5x plus 6y plus 7z. V is equal to 6x plus 5y plus 9z and w is equal to 3x plus 2y plus lambda z, and density is equal to rho naught exponential power minus 2t. Understood? We'll be using this equation, del rho by del t plus del by del x of rho u plus del by del y of rho v plus del by del z of rho w equal to 0. Okay? Now just put all the values here. It will be del by del t of rho naught e power minus 2t plus del by del x of so better would be density is common everywhere, right? So we can take this outside. We can take this outside. So it is density same everywhere. So we can take density outside, density del u by del x plus del v by del y plus del w by del z. Okay. Del by del t of rho naught e power minus 2t, it will become minus 2 rho naught e power minus 2t plus rho is rho naught e power minus 2t, and del u by del x will be 5, del u by del y will be 5, del w by del z will be lambda. Okay. So what I can do is we can take rho naught e power minus 2t common, minus 2 plus 5 plus lambda equal to 0. Okay, and from here we can say lambda will come out as minus 8. Okay, lambda will be minus 8. Have you got the answer, everyone? Sayyid have got the answer. Next question, a two-dimensional flow is described by the velocity components u is equal to 5x cube and v is equal to minus 15x square y. Velocity and acceleration at a point P where x is equal to 1 meter and y is equal to 2 meter respectively are. So we have to find the velocity as well as acceleration. The x and y coordinates are given, right? So how are we going to find the velocity? Very good, your answer is correct. Option C is the right answer. How are you going to find the velocity? So we know that resultant velocity v will be equal to square root of u square plus v square, right? So u is equal to 5 into x cube. 5 into x is 1 cube, that is 5. And v is equal to minus 15 x square y. Minus 15 into x, that is 1 square into 2. That will be minus 30. So resultant velocity will be, so velocity will be square root of 5 square plus minus 30 square. So you will get the resultant velocity from here. That will be 9 square root of 925, which will be 30.41. Are you getting 30.41 meter per second? Okay. Now how you will find the acceleration? You have to find the acceleration at point P. So we have to find the acceleration in the x direction and y direction, and then we have to find the total acceleration. So total acceleration will be square root of acceleration in the x direction plus acceleration in the y direction. Okay. Do you want me to end the session? You guys are not feeling interested to solve the questions. अगर देखिए आप लोगों को क्वेश्चंस नहीं आते सॉल्व करने तो कोई बात नहीं. when you will try to solve the question, definitely you will understand it. Okay, but अगर solve ही नहीं करेंगे then no point. Acceleration in the x direction will be u del u by del x plus v del u by del y. U is equal to 5x cube. 5x cube. So del u by del x will be equal to 15x square and del u by del y will be equal to 0. So 5x cube into 15x square will be acceleration. Okay. Whose speed is slow? My speed is slow. See, I can increase the speed, no problem. You guys please increase. If you guys are gonna increase the speed, I can increase my speed, no problem. X is equal to 1, right? Since x is equal to 1 meter, it will be 75 into 1 power 5. That is 75 meter per second square will be acceleration in the x direction. Acceleration in the y direction will be u times del v by del x plus v times del v by del y. Now v is equal to minus 15x square y. V is equal to minus 15x square y. Okay. So del v by del x will be equal to, del v by del x will be minus 30xy and del v by del y will be equal to minus 15x square. Just put these values here. U is 5x cube, del v by del x is equal to minus 30xy plus v, which is minus 15x square y, into del v by del y is minus 15x square. Okay, just put the value of x as 1 and y as 2 meter. In this equation, you will get the value of ay. You will firstly get this result as minus 150 x power 4 into y plus 225 x power 4 y square, y. Okay. So we can put the value of x as 1 and y is equal to 2 and you will get the value of, you will get acceleration in the y direction, which will be 150. Are you getting 150? So we have got acceleration in the y direction is 150, in the x direction is 75. Square root of 75 square plus 150 square will give you the total acceleration, which will be 167.70 meter per second square. So option A will be the answer. Yes, any doubts? Any doubt for the question? From fluid kinematics, you can expect that there can be a question from acceleration and velocity. Yeah, total acceleration is correct. Sayyid, your answer is correct. Anyone else got the answer for this? Total acceleration. Moving on to the next question. An open cylinder tank of 2.2 meter height and yes, correct. Your answer is option A. Very good. An open cylinder tank having 2.2 meter height and 0.6 meter diameter contains water for a depth of 2 meter. If cylinder is rotated about its vertical axis and paraboloid touches the bottom of cylinder, then amount of water spilled and corresponding angular speed are. How are you going to solve this question? So we are having an open cylinder, okay? Open cylinder is there and it is containing the height of the cylinder is, the total height of the cylinder is 2.2 meter and the diameter is, or we can say the radius of the cylinder will be, the radius is 0.3 meter. Okay. It contains water at a depth of, it contains water up to the depth of 2 meter. This is the initial level of water. Initial level is this. Now when it is rotated, the paraboloid touches the bottom. When paraboloid touches the bottom, you have to find the maximum speed. So the maximum speed will be equal to सर ये तो वॉर्टेक्स का प्रॉब्लम है. यस नंदी, वॉर्टेक्स का प्रॉब्लम है क्या? एग्जाम में नहीं आएगा ये? इज इट नॉट गोइंग टू कम इन द एग्जाम? बताइए. एग्जाम में आएगा। So depth of the paraboloid is equal to height of the cylinder is equal to 2.2 meter, and this is equal to omega square r square by 2g. From this calculation you will get omega. 2.2 meter is equal to omega square into r square 0.3 square divided by 2 into 9.81. You will get omega from here. Tell me the value of omega. बताओ भाई ओमेगा कितना आएगा आप लोगों का, जल्दी बताइए. Tell me everyone. Are you getting omega as 21.89 radian per second? Yes. Now I'm increasing my speed. Please increase your speed also quickly. This is the concept of vortex flow, force vortex flow in an open cylinder when the fluid is rotated and when the water is also spilled out, right? When the vortex of the paraboloid touches the bottom, some water will be spilled out, and this condition, the total depth of the paraboloid, which is this, will be equal to height of the cylinder. That is equal to omega square r square by 2g. From there you will get the value of omega 21.89. Got the answer everyone? Tell me quickly. Yes. Now we need to calculate the value of, we have to calculate, do a simple calculation, volume of water left in cylinder. Left in the cylinder will be equal to volume of the cylinder minus volume of the paraboloid, right? So volume of the paraboloid will be, volume of the paraboloid is equal to half of the volume of cylinder. It is just half of the volume of cylinder. So volume of water left in the cylinder will be equal to, volume of cylinder is pi r square h minus volume of the paraboloid is half of pi square h by 2, right? So from here you will get r is equal to 0.3, radius of cylinder, height is 2.2. Just put the values, you will get volume left in the cylinder. Come on, solve it everyone. 0.3110 meter cube. Are you all getting this value? Tell me quickly. Are you all getting this value for volume of water left in the cylinder? Now, this is the volume left in the cylinder, Final volume we can say, final volume of water. Okay. Now, can you find the original volume of water? Original volume of water or initial volume of water is equal to pi r square into h. Now this h is this h, 2 meter, right? Understood? So it will be pi into 0.3 square into 2. You will get the original volume, which will be 0.565 meter cube. Now, if they say that initially the volume was this much, finally the volume is this much, can you tell the volume of water spilled? Amount of water spilled, can you tell in meter cube? Yes. Volume of water spilled will be original volume minus final volume. Original volume is 0.565. Left final volume is 0.311. Yes, we will get the value of volume of water spilled, which is 0.254 meter cube. The answer will be option C. Are you all getting this answer? Sayyed, Nandi, वेरी गुड. तो शुरुआत में आए थे कुछ लोग बहुत जोश जोश में, 15-20 students, but then they thought, अरे sir is solving the question so slowly. So we can't, always run in a race, right? This is a question of a bend, right? We have to do the questions like a tortoise. Firstly, I have to save my energy, then I will increase my energy. I have the experience of teaching there are so many questions, and don't worry, I will take all the questions. I promise you. A 45-degree reducing bend is connected in a pipeline. The diameter at the inlet and outlet is 600 mm and 300 mm. The intensity of pressure at the inlet and outlet is given. The force exerted by water on the bend. Force exerted by water on the bend along the pipe axis is. Discharge or flow rate is given, 0.6 meter cube per second. Right? So how are you going to solve the problem of bend? This is a question of bend. So we are having this bend which is a 45-degree bend like this. Okay. And the angle of the bend is 45 degree. And let's say this is 1, this is 2, inlet, outlet. So we have to find the force on the bend. First of all, the inlet diameter, initial inlet diameter is equal to 600 mm. That is 0.6 meter. Outlet diameter is equal to 300 mm, which is 0.3 meter. And the discharge is equal to 0.6 meter cube per second. So if you know the discharge, if you know the diameter, can you find the velocity? Yes, yeah, we have to use the momentum equation, correct, Nandi? But firstly, for that, we have to find the velocity. Initial velocity will be q by a1, that is discharge 0.6 divided by a1 pi by 4 into d1 square, right? 0.6 pi by 4 into 0.6 square. So you will get the initial velocity, which will be 2.12 meter per second. Similarly, you can get the final velocity. V2 will be equal to q by pi by 4 d2 square. You know the discharge, you know the diameter, you can find the V2. So V2 should come out as 8.488. Firstly, confirm me if you are getting these two values, V2 and V1. Yes, 2.122 and 8.488. Then we'll apply the momentum equation. Then we apply the momentum equation and we'll get the answer. Come on, tell me everyone. So let us say the force in the x direction is Fx. Okay, the pressure here will be P1A1, right? This angle is 45 degree. So if apply, is it the correct formula? Applying momentum equation. Which formula is incorrect? Velocity is equal to discharge by area. Any doubts in the formula? Applying momentum equation, you will get pressure force at the inlet plus the force in the x direction. We'll apply the momentum equation in the x direction. Okay, minus P2 into A2 cos of 45 degree is equal to mass flow rate into V2, or it should be rho into Q, right? Mass flow rate or discharge? It should be rho into Q, right? Discharge is given, flow rate is given, na? So it should be rho into Q, V2 cos 45 degree minus V1. Okay, we'll apply this formula and P1 is given, initial pressure is 88.3, Final pressure is given. Theta is given. Yes, yes. Apply this formula, you will get the answer. You should get the value of force from here. Tell me, are you getting the answer? Force in kilonewton. Just put the values. P1 is equal to 88.3 kilopascal. Just use this momentum equation. P2 is 54.5 kilopascal. A1 will be equal to pi by 4 into D1. D1 is 0.6 initial diameter, and A2 you will get from here, that is pi by 4 into 0.3 square. You will get A2. 45 degree you can put. Initial velocity. Initial velocity is 2.122. Final velocity is this. Put all the values, you will get the answer. Okay. Hey, have you got the answer? Have you got the answer? The force Fx you should get as minus 19.914 kilonewton. This should be the force. This will be the force on fluid. So on bend you have to find force on the bend will be equal to plus 19.914 kilonewton, because they are asking the force on the bend, force of by water on the bend, that will be 19.91. Yes. Velocity V1 is equal to 2.122 and V2 is equal to 8.488. Put the values. Have you got the answer, everyone? Tell me. मेहनत करने वाले लोग कुछ ही होते हैं, रिजल्ट भी उन्हीं का मिलता है सिर्फ. Initially some people came in the class, they thought sir will be discussing some very easy questions. See, I have mostly taken questions of 2 marks. Okay, I have not taken any question of 1 marks for this session, because I believe that 1 marks question you can easily solve. They are simple formula based questions. You can apply a single formula, you can get the answer. There is a reason I have taken difficult question for this session, so that you are able to solve the questions which are like difficult, or you can say little bit conceptual questions. Okay, this is also formula based question, but have you got the answer? So what is this question? Pressure difference. A straight stretch of horizontal pipe of 5 cm diameter was used in the laboratory to measure the viscosity of a crude oil, right? During the test run, a pressure differential of 18,000 Newton per meter square was recorded from 2 pressure gauges located at 6 meters apart on the pipe. The oil was allowed to discharge into a weighing tank, and 5,000 Newton of oil was collected in 3 minutes duration. You have to find viscosity of oil. Such a difficult question, right? So straight stretch of horizontal pipe. Straight stretch of horizontal pipe is there. A straight horizontal pipe of a constant diameter, and diameter is also fixed. It is 5 centimeter. Okay. We have to assume something. Horizontal pipe, constant diameter, we have to assume something. Horizontal pipe and constant diameter. Constant diameter. So we have to assume that it is laminar flow. Okay, we have to assume it is laminar flow. For laminar flow, we know that the pressure drop is equal to 32 into, yes, very good, you have used the correct formula, mu into average velocity into L divided by d square, diameter square. Okay, by using this formula you can find the viscosity. By using this formula we can find the viscosity. We have to find the viscosity, you will get the viscosity from here. But for finding the viscosity we have to find the average velocity. We have to find the average velocity, and how we will find the average velocity? Now, $9,000 is what? Now we know that the oil was allowed to discharge into a weighing tank and 5,000 liters of oil was collected in 3 minutes duration. Okay. So now we know that weight is equal to M into G, and or weight per second. How much time? 3 minutes. Weight per time is equal to mass flow rate into G. So we can say weight is equal to weight per time. Time is equal to mass flow. We can say weight per time, per unit time, is equal to M in mass flow rate into G. Mass weight is equal to density into discharge into G. Weight by time. So weight will be equal to rho into Q into T into G, where T is the time. Weight is equal to 5,000 Newton. Density is into G. Specific weight is 9,000 directly. Okay. Rho into G into T into Q. We can find discharge from here. So weight is equal to, we have got weight is equal to rho into G into Q into T. Weight is how much? Weighing tank is weighing 5,000 Newton. 5,000 Newton. Okay. Density rho into G. Specific weight. Specific weight is directly Newton per meter cube. It is given 9,000. 9,000 directly into Q, and time is, this oil was allowed to discharge into the weighing tank and 5,000 Newton of oil was collected in 3 minutes duration. So time is equal to how much? 3 minutes. So 3 into 60 seconds. So you will get the discharge from here. Discharge will be 5,000 divided by 9,000 into 3 into 60. Understood? Firstly, we'll get the discharge from here, which will be 3.08 into 10 power minus 3 meter cube per second. Now this discharge is equal to area into velocity, average velocity. Area of the pipe is, diameter is given 5 centimeter. So this average velocity will be equal to discharge by area. Discharge is 3.08, 10 power minus 3. Area is pi by 4 into 0.05 square. So from here you will get the value of average velocity, which will be 1.572 meter per second. What happened, guys? Have you got bored of the lecture? Yes? Don't want to solve question? Should we end the session? See, I will take the class until unless you guys are, you won't have to solve the questions. I have taken all the good questions for this session. Very good conceptual questions. Now pressure difference is given 18,000. This pressure difference is already given the question. Pressure difference is given. So P1 minus P2 is equal to 32 mu into average velocity into L by D square. Pressure difference is 18,000, right? 32 mu, you have to find average velocity is 1.572. Length is 6 meter apart, right? So this 6 meter apart is the length. Divided by diameter is 0.05 square. Solve it, you should get the value of viscosity from here. 0.1492 Pascal second. Are you getting the viscosity? 0.149, very good. Sayyed, your answer is absolutely correct. Anyone else getting this answer? Have you understood the question? A very nice question, very good question. And the interesting thing is how we have found the discharge. Weight per unit time, right? Weight per unit time is equal to mass flow rate into G. Mass weight is equal to density into discharge into G. Weight will be equal to rho into Q into T into G. And from here you have found the discharge. So this formula is very important. Okay. That's why I'm saying that I have taken very good question, but if you don't value them, what I can do about it? A power transmission pipe of diameter 7.5 centimeter and 4 centimeter long is fitted with a nozzle at exit. The inlet is from a lake with water level 48 meter above the center line of the discharging nozzle. Consider the value of friction factor is equal to 0.03. Calculate the maximum power in kilowatt which can be transferred for optimum diameter of the nozzle. Now, I hope you guys have studied the theory of power transmission through nozzle. Have you studied the theory of power transmission through nozzle? In the vision course, in resultant, we have taught you this. I have taught you this. Power transmission through nozzle. And for maximum power transmission, if you remember, I told you one formula, and that formula was area ratio. Area ratio is basically area of the pipe by area of the jet is equal to square root of 2 into friction factor into length divided by diameter. Just solve this. It is 2 into friction factor is how much? 0.03 into length is 400 meter. This is 400 meter. Diameter is 7.5 centimeter. That is 0.075 meter diameter. From here you will get the area ratio. Area ratio will be 17.89. 17.89. This is area of the pipe to area of the jet, right? Now, you know that, that condition was for the pipe, power transmission through pipe. Here we are talking about nozzle also, okay? You need to find the maximum power for optimum diameter of the nozzle. So area of the pipe by area of the jet we have got as 17.89. Area of the pipe will be pi by 4 into square of diameter of the pipe square divided by pi by 4 of, you are seeing the formula first time. Have you attended the lecture? I have done a derivation that I have done this derivation that for maximum power transmission through nozzle, area ratio is this. I have told this formula in the class. If you have attended the vision class, you can see that. I have taught this in the vision lecture. So you can find the ratio of diameter. This is going to get cancelled out. Diameter of the pipe by diameter of the jet will be equal to square root of 17.89. Okay. So diameter of the pipe by diameter of the jet is square root of 17.89. You can see the vision course. If you have really joined the vision course and you have studied from me, I know I have seen in my notes, I have taught you this formula. Now diameter of the jet will be equal to diameter of the pipe, which is 7.5 centimeter divided by 4.23. So you will get diameter of jet will be 1.77 centimeter. Okay. So we need to find the value of, for maximum power transmission, I told you that head loss due to friction is equal to total head by 3, right? This I have taught you, remember? Total head is how much? The total head is 48 meter, right? So 48 meter by 3, it will give you the head loss due to friction. Head loss due to friction will be 16 meter. So net head available at outlet of the pipe will be equal to, what will be the net head? The total head minus head loss due to friction will give you the net head, which is 48 minus 16, that will be equal to 32 meter. Okay, net head available. Now this net head you don't want to solve this question? This net head is converted into velocity head, right? It is converted into velocity head. So velocity of the jet square by 2g, this is velocity head, that is equal to 32. So from here you will get velocity of the jet. Velocity of the jet will be equal to square root of 2 into 9.81 into 32. Velocity of the jet will be 25.06 meter per second. Okay. So we have got the velocity of jet. Now discharge through the jet will be equal to power transmission through pipe is through pipe I will not take the class further because I am not liking the response you guys are showing for the class. Next time I will tell Dheeraj sir I will not take the class. Okay, I'm not liking the kind of response you are showing for this session. Maximum power transmission through the pipe is, what is the meaning of this emoticon सूरज? आपसे क्वेश्चन सॉल्व नहीं हो रहा है, ये फॉर्मूला होता है मैक्सिमम पावर ट्रांसमिशन का. हाँ, किस बात की खुशी हो रही है तुमको? It will be 9.81 into 1000 into Q into H minus HF is 32. You have to calculate this. How will you find the discharge? Discharge will be equal to pi by 4 into diameter of the jet square into velocity of the jet. We have calculated the diameter of the jet and velocity of the jet. That's the reason we have done all this calculation. Diameter of the jet is 1.77, velocity of jet is 25.06. Will 1.77, and if you see this question in the exam, don't 1.77 10 power minus 2 square into velocity of the jet is 25.06. You can get the value of discharge from here, which is 0.00616. Put the value. And you will get the power transmission, that is 1.934 kilowatt. Okay. चलो एंड करें सेशन को, और यू वांट टू सॉल्व सम क्वेश्चंस लेफ्ट, or you are bored from the session? Looks like that you guys have shown such a good response for this session, and I'm thinking of whether I should take the next session or not. The mean drag coefficient for a laminar boundary layer over a flat plate was found to be this: if all the other flow factors remain same and length of the plate is decreased to 1/4 of its original value, the drag coefficient would be equal to. Should we end the session? For laminar flow over flat plate, we know that drag force is equal to 1.328. This is called mean drag force, square root of Reynolds number. Or we can say mean drag force is equal to 1.328 square root of rho VL by mu. So mean drag force is inversely proportional to 1 by square root of length, right? Yeah, Laplace solution will be used. So coefficient of drag 2 by coefficient of drag 1 is equal to square root of L1 by L2. So they are saying the length of the plate is reduced to 1 by 4th, that is L2 is equal to L1 by 4. What will happen to the drag coefficient? Very good. Tell me the answer quickly. It will be CD1 and this will be 2. That is 2 times of that. 2 times of this will be the answer, that is 0.03. Okay. Option C, very good. Next question. A sphere model of 10 centimeter diameter is tested in the water flowing at 2 meters per second. The drag force is measured as 5 Newton. Prototype of 1.5 meter in diameter is tested in the air with a dynamic similarity condition. Density of water is 1000, density of air is this, viscosity of water is this, viscosity of air is this. Find the drag force in prototype. Want to solve this question? Okay, let's take this as the last question because anyways the session name is fluid mechanics important questions. So I will not take the hydraulics question. You can solve the hydraulic question later on, maybe in some other session. So this is the last question of fluid mechanics from dimensionless analysis. Dimensionless analysis. Let us take this as the last question. हाँ, कौन सा मॉडल लॉ लगेगा? नंदी, वेरी गुड. रेनॉल्ड्स मॉडल लॉ लगेगा. क्यों लगेगा? Why Reynolds model law will be applied? Tell me the reason. Under which condition we apply the Reynolds model law? Under which condition you apply the Reynolds model law? Can you tell me the condition? Flow through pipe, fully submerged flow, right? In this application we apply the Reynolds model law. So try to solve this question. This is the last question. First of all, what is the formula for drag force? Drag force is equal to half rho into CD into A square. We can simply say drag force will be equal to both Reynolds model prototype is equal. Okay. So how are we going to apply this formula? So Reynolds model law is applied. We apply the Reynolds model law. Which says that rho into V into L by mu of model is equal to density into velocity into L by mu of prototype. Okay, this is Reynolds model law. So first of all, what is given in the question? They have given diameter of the prototype. Diameter of the prototype is equal to 1.5 meter. See, prototype of 1.5 meter diameter. Okay, diameter of the model is 10 centimeter. That is 0.1 meter. Density of the prototype is using what? Prototype drag force is measured as 5 Newton. Prototype of 1.5 meter is tested in air. So density of air will be density of the prototype, which is 1.2 kg per meter cube. Okay. And viscosity of the prototype will be equal to, viscosity of prototype is viscosity of air, which is this 1.78 into 10 power minus 5. Okay. So firstly, we'll find the scale ratio. A scale ratio for length. A scale ratio for length will be equal to length of the model, or we can say diameter of the model, diameter of the prototype by diameter of the model, which is prototype is 1.5 by 0.1. You will get 15. 15 will be the scale ratio for length. Density ratio will be scale ratio for density of density will be, that will be density ratio, density of the prototype by density of the model, which will be first of all, what is force ratio? What is drag force? Drag force will be equal to density rho into L square into V square. Okay. So this is force of the prototype, force of the model, density right. So what is force ratio? The force ratio will be equal to force of the model by force of the prototype will be equal to we have to find the scale ratio, drag force in the prototype. So drag force is measured as 5 Newton. Have you solved the question? Yes? Yeah, velocity ratio is required here. We need velocity ratio. How will find the velocity ratio? We will use the Reynolds model law, that density of the prototype, velocity of prototype, length of the prototype, diameter of the prototype divided by viscosity of the prototype is equal to density of the model, viscosity, velocity of the model, density of the model divided by viscosity of the model. So we can find the value of velocity ratio will be equal to, how will find the velocity ratio? Vp by Vm, which is the velocity ratio, will be equal to rho m by rho p into dm by dp, right? Rho m by rho p into u this, right? So this is what? 1 by density ratio into 1 by scale ratio, and this is viscosity ratio. So velocity ratio will be equal to what? Viscosity ratio divided by density ratio and length ratio. Okay? Understood? So we have got the length ratio as length of the diameter, this is 15. Density ratio will be, density of the prototype is 1.2 by 1000, and we'll get the viscosity ratio. Okay. We'll get the viscosity ratio because viscosity of water is given, viscosity of air is given, we'll get viscosity ratio. We'll get the scale ratio for this. Force ratio will be equal to, density rho r into L r square into VR square. This will be the force ratio. So from here you will get the force of the prototype. Force in the model is equal to, force in the model is 5 Newton, right? So we can get the force in the prototype from this. Understood the question? Firstly, you will find the VR. VR is important, that because it is viscosity ratio divided by density ratio divided by scale ratio of length. Okay, length ratio, density ratio, we can find the viscosity ratio also. Viscosity of the prototype by viscosity of the model. So you will get all these ratio. You will get the velocity ratio, right? Now force ratio is equal to what? Force ratio is equal to force of the prototype by force of the model. That is equal to density ratio into L r square into VR square. Okay. Solve it. From here you will get force in the prototype as 1.32 Newton. You should get this answer. Are you getting this answer, everyone? Tell me. The viscosity of water is this, viscosity of air is this, density of air is this. Water will be having density of 1000. Yes, getting the answer 1.32 Newton. 1.32 Newton will be the answer. That's all for this session. Thank you so much. Hydraulics question I am not solving here, but I will give you the hydraulic question in the PDF format. Okay, I will share the PDF with you guys. Okay, in the PDF you will find the question of hydraulics and you can solve these questions. Thank you so much everyone for joining me for this session. Thank you everyone. Have a nice day. Thank you.